Let's remind ourselves what we know about the sine and the cosine. Let this be a scaled version of the unit circle such that it has radius r. Then remember how we counted angles. We start always from this point, and we always move in this direction to 90, 180, 270, and then 360, which is the same as 0 degrees. And so each point on the circle we can associate with some directed angle here, which in this case is approximately 50 degrees. Now, of course, because this is a radius of the circle, this has length r, and I'm labeling this angle alpha. Then the sine of alpha can be found by taking the projection onto the vertical axis, in this case it's this projection, and then multiplying by r because we have scaled the unit circle by a factor of r, and so the length of this projection is r times sine of alpha. Now because this is a rectangle, we know that the other side of the rectangle, this side, is also r times sine of alpha. The cosine of alpha we can find when we project onto the x-axis. So this length here would be r times the cosine of alpha. Here note that distances on this side of the x-axis are taken with a positive sign, and distances on this side of the axis are with a negative sign. And here the distances are positive on this axis, and here the distances are negative on this axis. Because alpha is between 0 and 90 degrees, then both the sine and the cosine will be positive, because the cosine lies on the positive side of the x-axis and the sine lies on the positive side of the y-axis. I deleted the useless part of the picture, and now we can zoom in and see what we've got. We've got that in a right-angled triangle, where one of the acute angles is alpha, if the hypotenuse is r, then the side opposite to the angle alpha is r times sine of alpha, and the side adjacent to alpha is r times cosine of alpha. This is really important. Every time you see a picture like this, you can say, aha, this is r sine of alpha, and this side is r times cosine of alpha. And what if you're in this situation, in which you know that the red side is x? Then what is the blue side and what is the black side? Well, the black side would be x divided by the sine of alpha, and the blue side will be x times cosine of alpha divided by the sine of alpha. You see how that works out? The sine of alpha is this side divided by this side, and therefore this divided by this should be x divided by sine of alpha. X cancels out, and we get 1 divided by sine of alpha, which is sine of alpha. And then for this side, we know that this side divided by this side is cosine of alpha, and therefore this times cosine of alpha equals this, which is obviously true. Lastly, what if this side is y? How do we find the other two sides? Well, we know that this side times cosine of alpha equals this side. And so this times cosine of alpha cancels out, is y, which is here. And we know that this side is this side times sine of alpha, which is obviously true. Just put a sine of alpha right here, and then we get this expression. Now let this side be x, but let's consider this time the triangle with respect to the third angle, which would be 90 minus alpha because of the sum of the angles in this triangle. If this is x, then, with respect to this angle, this side must be x times the sine of 90 minus alpha, because the sine of 90 minus alpha would be the side opposite to the angle divided by the hypotenuse. And the cosine is the side adjacent to the angle, in this case is the red side, divided by the hypotenuse. Now again, with respect to this angle alpha, if this is x, then this side would be x times cosine of alpha, and this side would be x times sine of alpha. This is how we get these two equalities. In both equalities, we can cancel out the x and we get cosine of 90 minus alpha equals sine of alpha, and sine of 90 minus alpha equals cosine of alpha. The optional problem is we have a right-angled triangle, and this is its incircle. The 2 points of tangency here and here are connected with a line, and this line intersects this line at this point. Then we label this distance with y, and this distance with x. We need to prove that x equals y. And here's the solution. Let's connect the center of the circle with the 3 tangency points. Then we get that the 3 red segments are equal because these are radii in the circle, and that each of the red segments is perpendicular to one of the sides of the triangle because of the tangency. Furthermore, if this is x, then this is also x because these are tangent lines to the circle from the same point. We see that this quadrilateral has all right angles, and therefore it's a rectangle. And so this side equals this side, and this side equals this side. But these two sides are equal, and therefore this is a square. Now let's call this angle here beta. Then, because this is a line from a vertex of the triangle to the incenter of the triangle, then this must be an angle bisector of this angle, and therefore this angle is also beta. We have that this triangle is isosceles, and that this angle is 2 times beta, Therefore, this angle equals 90 minus beta. Now, since this is 90 minus beta, it follows that this angle here is also 90 minus beta, because we have two straight lines here and here. Now, in this triangle, this angle is 90 degrees, and this angle is 90 minus beta, and so this angle is beta. Now I'm going to zoom a little bit. I'll consider this right-angled triangle. We have that this angle is beta, and this side is x. And therefore, this side must be x times sine of beta divided by cosine of beta. And now since we have a square here, then this side is also x times sine of beta divided by cosine of beta. Now consider this triangle. Since this side is x times sine of beta divided by cosine of beta, then this side would be x divided by cosine of beta. And this side would be just x. Essentially what we did here is we used the sine and the cosine to prove that this triangle is congruent to this triangle, which we could have done by noticing that they have one common side here and three common angles. In future videos, we're going to see how using the sine and the cosine could lead to non-trivial results.